Whenever you walk into a modern building, you're literally surrounded by safety features. But it's not just about the obvious stuff like sprinklers and fire extinguishers. Beyond what you can see, there's this whole world of invisible rules, a really complex set of codes that are quietly working around the clock to keep you safe. So let me ask you this. What do you think is really keeping you safe when you're on, say, the 20th floor of an office building or in a hospital? If you had to bet on just one thing, what would it be?
Well, the answer isn't a single device you can point to. It's actually a whole system of codes and standards that controls pretty much every single part of how a building is designed and put together. These are the unseen rules that we're going to talk about.
All right, here's our game plan. We're going to start with what these invisible safety rules are all about. Then we'll get into the surprising details about cables, smoke, and air. After that, we'll look at what happens when you poke a hole in a building's armor and the classic dilemma between security and escaping. We'll also touch on why design has to work for everybody and wrap it all up with a really important point. Code is not a suggestion. So, where do these rules even come from? Well, they're not just made up. They're written by some of the heavy hitters in the world of building safety. We're talking about organizations like the National Electrical Code, the NEC, and the National Fire Protection Association, the NFPA. You can think of their rulebooks as the absolute foundation of modern safety. Okay, let's dive into our first big area, cabling. Now, you might think the biggest risk with a cable is an electrical fire, right? But the code is actually way more concerned about a fire's deadliest and quietest weapon. And here it is. This is the critical danger. When a fire breaks out, the plastic jacket on all those cables starts to melt. And if those cables are sitting in a space that handles air circulation, that toxic smoke gets sucked right into the HVAC system and pumped through the entire building. That is what the code is absolutely laser-focused on preventing. So this is where it gets interesting, because the code actually breaks this down into two key areas. First, you've got what's called plenum space. That's the area above a drop ceiling that's used for air circulation. The big risk there is smoke. So the code says you have to use special plenum-rated cable. Then you've got riser spaces. Those are the vertical shafts running between floors. The fear here is that fire could literally climb the cable like a rope. So you need a different riser-rated cable specifically designed to stop that from happening. And this leads to a fantastic piece of advice that all the pros live by. It's a really simple rule of thumb. When you're not sure which cable to use, just go with plenum. Yeah, it's a bit more expensive, but it's universally compliant. You can always use a plenum cable in a riser space, but you can never, ever use a riser cable in a plenum space. It's a great way to stay safe. Okay, so we've got our special cables, but what about the walls those cables have to pass through? We're talking about fire-rated walls now, which are basically a building's primary defense against a spreading fire.
This is so important to get right. The moment you drill a hole in a firewall to run a cable, that wall no longer has a fire rating. It's done. Think of it like punching a hole in the side of a submarine. The whole system is compromised, and you are legally required to fix it. The whole process is actually pretty simple, but every step is absolutely critical. So you start with your firewall, which is your armor. You need to run a cable through it. So you have to make a hole, which breaks that armor. And the final step, which is mandatory, is to use a special material called a firestop to seal that hole back up and get that wall's protective rating back. So what is this magic material? Well, the stuff used for firestopping is called Intumescent. It's kind of a fancy word, but what it does is brilliant. When it gets hot, it expands. It literally swells up to completely choke off the opening, blocking both flames and smoke. Your regular caulk from the hardware store is just going to melt away. This stuff does the exact opposite. All right, now for a really fascinating conflict that exists in just about every building you've ever been in. The need to keep bad guys out versus the need to let everyone escape in an emergency. It's this constant push and pull between security and life safety. And here's what it all boils down to. When a fire marshal shows up to inspect your building, they honestly don't care how cool your security system is. Their number one top priority is egress, which is just a technical term for making sure every single person can get out of that building safely and quickly during an emergency. This is a huge deal for doors with those big magnetic locks. To be up to code, a maglocked exit door usually needs 3 separate, redundant ways to unlock. A motion sensor that sees you coming, a physical push to exit button you can press, and a direct link to the fire alarm that automatically cuts power to the lock if the alarm goes off. It's all about having backups for your backups.
And, there are even rules for the buttons themselves. When somebody hits that push to exit button, the code says the door has to unlock and stay unlocked for at least 30 seconds. This is to make sure the door doesn't relock on someone who's moving a little slower or trying to get out in a panicked crowd. Now, there is one special exception called delayed egress. You might see this in a hospital, for example, to prevent a confused patient from wandering out. In that case, when you push the exit bar, a loud alarm goes off for 15 seconds before the door actually unlocks. But this is super strictly regulated. You are absolutely not allowed to use this in places like schools or auditoriums.
Now, safety isn't just about fire and escape, it's also about accessibility. And that's where another critical layer of rules comes in, from the Americans with Disabilities Act, or ADA. These rules make sure that buildings are safe and usable for everybody, no matter their physical ability.
And these rules get really specific, and for good reason. For instance, a card reader has to be mounted low enough so someone in a wheelchair can easily reach it. An interior door can't require more than 5 pounds of force to open. It can't be a struggle. And get this, a security camera isn't allowed to stick out more than 4 inches from a wall to prevent someone who's visually impaired from accidentally hitting their head. Every little detail is about creating a truly safe space.
Okay, so we've covered a lot. Cables, firewalls, doors, accessibility. After all of that, what's the single most important thing you should take away from all this? This is it, the bottom line. None of the stuff we've talked about is optional. These aren't just good ideas or best practices. They are legally enforceable requirements. If you fail to follow them, you're looking at failed inspections, expensive rework, maybe even big fines. But most importantly, you are putting people's lives at risk. It's that simple. And that's our look at the unseen rules of building safety. So I'll just leave you with this final thought. The next time you walk through an office building, a school, or a hotel, just take a second to look around. Now that you're in on some of the secrets, what do you see differently?